Right, so today we're going to be talking about what batteries I'm going to be using in the motorbike. Pardon me. These are Nissan Leaf Gen 2 cells. They are very nice because they're a very compact unit. They're quite heavy, but they're very compact. They're protected as they have steel. It's only very thin, it's like 1 mil, 0.5 mil thick. Pardon me. But it has got some protection to the cells. Now, I was going to make another 18650 battery or something like that, or my own lithium iron phosphate pack, but I didn't want to mess around with anything like that because I had to do that before. And it wasn't particularly fun. So what I've done is I've bought some of these to test and to have a look at, and so far these are absolutely brilliant. I've got 4 of them, and I need to get another 2 of them. If we just grab one of these, try not to drop it on my foot or anywhere else because it'll probably blow up. Bear with me. Just going to set this down in here. As you can see, it fits very nicely into the frame of the bike, which is very handy because when I got these I didn't think they were going to fit, but then I just slotted one in. It fits perfectly in the frame, and I can put 2 under the tank, and I'm going to put 1 up the front here, 1 behind, and 2 on the bottom under the motor. Talking about the motor, there's none in there. Taken it out for welding the battery mounting tabs in. Heavy little thing, this motor. But this is also very good so far. Sorry, I've got a bit of a cold at the moment. But this has been brilliant so far. Just wrapped these wires on here with some of this Tessa tape, this harness bundling tape. It's quite good. Didn't get the heat rated stuff though. I just got the inside of the car stuff. So I might have to change that over some point, but it seems alright for now. It's just to give the wires some extra protection from abrasion. What I'm going to be doing with this battery is I'm going to have another battery pack on top of this, obviously. This one would be wasted space, and then on top of that, these 3mm aluminium plates will be bolted on. Then I'll weld studding and mounting things to that. The contactor over there, I have to swing that round. So put this wire on there, so that this coil wire is coming out the bottom, so it can go straight to this one here. That one's for the ignition. And this wire is the positive of the controller, the ignition lead. So there's going to be don't know what they recommend. I think it was 4 amps plus whatever your contactor uses. I think that uses an amp and a bit, so maybe a 6 amp fuse, something along those lines, to the positive, which would be here. Now I've got the tank here. It looks absolutely awful. This is a mock-up tank. I will be getting a new tank once I know that everything fits. I fitted an isolator here, as you can see under this dust cap. On the inside it's got the wires attached to that. One of them goes to the contact, the other goes to the battery positive. That one there. And on the battery positive, now you may think, oh yeah, one more thing I was going to say. BMS is going to go here. BMS will only be handling charging and balancing. It will not be handling discharge. There will be no discharge protection on this whatsoever, like on a regular EV. Well, I mean, there will be some, but no active discharge protection. So on a regular EV, what you've got, your controller has a current limit in it. And the only other protection you have is either circuit breakers or some bloody big fuses. So I've got some of these, 325 amps, same as on the controller. and these go on the top of the battery like this. So then this end of the fuse goes to the isolator, which is up here. The other end of the isolator then goes to the contactor. Then the positive from this goes through a fuse to the positive from the batteries through the isolator. And then this, the charger positive goes straight to the battery positive, and this charger negative goes through this BMS. It may not, I might not even put it through the BMS. I might just use the BMS for balancing, because this can only handle a 50 amp charge, I think. And for my fast charger, I'm going to be charging at 100 amps or something thereabouts. I've done the wiring for the controller, or most of it. I've taped the harness as well for that. So that's got a gazillion plugs on the end of it. And you've got your CAN bus. Now this, if we ask, why is there a cardboard box in here? This is the same size as the charger. I've made a little cardboard box to see if the charger will fit. Because even though measuring stuff is all good, but I always like to make a cardboard template, because sometimes when you measure stuff you overlook things, and with this I know there's enough room, it will fit. And if not, there's always room under here between the motor and the battery to put a charger. But yeah, I'm going to be talking a bit more about these batteries, I think. Now this one's got a bit of wear on it. These terminal posts, I've got these bus bars. They are 50mm in length by 15.8 something millimeters in diameter. These here just go right under the bolts. And on top of the bus bar will go one of these. Oh dear. Now this is a 3D printed case to go over, or cover to go over the terminals. This is a PCB with a fuse on it. Because all my balance leads are going to be fused. Just in case anything happens. You may ask, what's this terminal for here? You've already got balance leads. This terminal is an isolated thermistor. So I'll be measuring the battery temperature straight from the terminals, which should, in this case, give me the most accurate temperature measurement, except for just sticking a thermistor straight in the pack, which is something I don't really want to do. I've got these so basically a bus bar goes on, then the balancing board thingy, thermistor on some cells, and then a 3D printed cover. Same thing for these middle ones, except for that no bus bar goes across here, just one of these and a 3D printed cover. But I think if you're building a motorbike or any other electric vehicle, try and get your hands on some original batteries from an electric vehicle, because these things have gone through all the safety tests, they've gone through the factory checks, they've been designed well, and they're reasonably safe. Also, they're very compact and have a very high energy density. These are 1670 watt hours each. So I'm looking at about 10 kilowatt hours for the whole pack, or thereabouts. Considering these are used, so they've got at least 80% or above remaining capacity. So maybe 8 kilowatt hours for the whole pack, which is pretty much for this little bike, so that should be enough. Considering that it will be a 125, only 11 kilowatts, an 8 kilowatt hour battery pack should get me quite a distance on this. Now, I think I've looked at a range of about, what was it? It was about 80 miles or something like that. I'll probably get about 60 miles of range out of this thing, and that's enough for me. This is going to be for city commutes only, and for short urban journeys, maybe some country roads and things like that. But aside from that, there isn't really much else to talk about. I've fitted the indicators, all of them. There's a load of metal dust on them because I've been doing a lot of angle grinding, cleaning off the original crap from the bike. This needs to get repainted because there's a load of shit everywhere. But I think there's not really too much else to do on the mechanical side of things except for building a motor mount plate and getting the chain over the frame so that it doesn't hit on the chainstay here. And then it's just electrical from there on, because I've got to mount these batteries. That's what I've done to mount these. Welded in 4 tabs under these holes. Then you've got this, which is M8 studding or M8 threaded bar. I've cut these for 2 batteries and 2.5 centimeters or 25mm of leftover bar on either end. These want to be about 190mm long, so 19 centimeters. And then they're exactly the right length to go through 2 battery modules, and you have 2.5 centimeters on either side, I believe. So you've got enough room. In my case, on top of this, on top of the second battery, there's going to be a 15mm aluminium block, and under that, the 3mm aluminium sheet. The reason I have a 15mm block is so that I can really put some tension on there and really clamp these packs tight, because in the battery, in the Nissan Leaf module, these are quite tightly squeezed together, and you don't want to go mad on them. Obviously you want something like hand tight or just over hand tight, but still that's quite a lot of force, so the 3mm sheet would just bend and deform because you've got a slight ridge here, and I don't want that, so I'm going to put 15mm block on top. Some of this stuff. It's probably overkill, but I'm going to do it anyway. The next thing is mount the heatsink to the controller and charger, but I can't do that until I've got the charger. And then the only thing left to do is to do all the wiring and get it through its MOT and through the MVSA tests, which I'm slightly worried about because I've heard a lot of people recently who have gone through the effort of building their e-bikes and then they've given up with their projects or given up with legalising it because of apparently it's a lot of effort to get everything right. But I'm thinking with this, because it was originally a road legal motorcycle, the only thing I've done is altered the drivetrain. I've done nothing aside from that except for make it ridiculously heavy. But I've seen that BMW makes an electric moped, and have a guess how much that weighs. 275 kilos, and that is a 125 as well, so I don't think weight is going to be too much of an issue with this, considering I think it's a max weight of maybe 150 or 160, so that's still 120 kilos lighter than the BMW one, so I think I'll be alright, to be honest. This is the charge port. Also has to go somewhere. I've used one of these weird connectors. I've got this off of an old solar inverter. Don't know what it's called, but it looks good. And it's rated for quite a bit of current. Just ignore the horrible welds on that, they don't look amazing. I didn't have my auto darkening welding helmet on me that day, so I couldn't really see what I was doing. But this has to go somewhere. I'm thinking it will probably either go in the tank, so I have one. I'll just grab the other thing I need. Just one of these little Anderson things. Bear with me. So much stuff everywhere. Yeah, another thing I need to do is clean my workshop again because it's got all messy again. So on this, I'll have my Anderson 120 amp. This will be for an external fast charger or power output, so you can use some of the power. You could connect, for example, I don't know, you can connect an inverter or something and run your mains gear off of it. I mean, it's 110 volts, so you can run sight gear off of it. Don't know why you'd want to do that, but this is for chargers mainly. I'm going to 3D print a mount that holds this and a second. I think I'm going to use a 6-pin connector. So this and then a 6-pin connector So the 6 pin is going to handle CAN bus data and safety stuff. So this will never be live because this will go through the contactor or through a second contactor. So basically these pins will never be live until you plug it into the charger. Then this, or the stuff on the bike, will communicate with the charger, telling it or asking it what it can deliver, if it's the right charger, and if everything's okay and it's all plugged in, it will energize these contacts and the charger will output power. And then this will probably work in a similar sort of principle. I'm probably not going to use any external sensing and communications with this because it's mains input only, there's no output, so it's perfectly safe. This will probably go next to that, or this will maybe go on top of it along with the 6 pin. This will come out the side of the tank and have like a little deployable flap thing so that you can open and close it as a lid. But I think that's about it for the bike build at the moment. So obviously it's around Christmas time, I'm going to be ridiculously busy, so I don't know whether I'll get more done until next year at some point. I'm probably going to start again. I'm going to do little things on it, but I won't be able to make my mounting plate or do any more welding because I've only got a DC TIG welder up there, so I can't weld aluminium. That's another thing I wanted to build at some point. I wanted to build a transistor block that allows me to convert my DC TIG into an AC TIG, but that's a side project that will happen at some other point, I think. I've just been thinking about it recently because I don't want to have to buy a whole nother welder. I've got too many of the things already. But I think that's about it. I won't be able to do anything on the aluminium side until at least the 2nd or 3rd week of January. But up until then, I will be doing loads of wiring with this cable. I've used 35 square mil in this. Absolutely huge cable. 35 square mil orange welding cable. Orange is quite handy because it looks like EV cable. Got to be orange because of the high voltage, so that people can tell. I probably shouldn't touch that or else I might get electrocuted. So that's good. This will probably have to be orange because it's an external high voltage connector. The other thing, the mains thing, will probably have to be orange. Little things like that, you know, just safety things. They help it get through the MVSA apparently. So that's about it. The display will need some work as well because currently it's not communicating with the Sevcon controller. It's not working. I was going to get a clear view, but again I made a template out of cardboard. They're this big. There's absolutely nowhere that I can fit something that size. I could put it there, you wouldn't be able to see the gauges. Put it in the tank, there wouldn't be any room for the BMS then. So that's sort of gone out the window. I might still get one, but I'd have to make a custom fuel tank. I have got enough alley for it. I've just bought a massive 8x4 sheet of aluminium at the scrapyard for an absolute bargain. 20 quid for a massive 8x4 sheet, 3mm thick. So definitely have enough alley to finish this project. Well, that's it. So I will see you people in the new year.